All right, so we will have a continuation of our lesson on arithmetic sequence. And as per our objectives, the same. Let us determine whether a given sequence is an arithmetic or not. And then we will use the recursive formula and we will add the explicit formula to identify the nth term of an arithmetic sequence. So let us go back or have a review on what is arithmetic sequence. So we have defined last time that an arithmetic sequence is a list of terms separated by a common difference d. Okay, the common difference is denoted by uh, d, right? Which is the number added to each consecutive term in an arithmetic sequence. We also defined last time that an arithmetic sequence is a linear function with a domain of whole numbers. So here are some examples. Okay, so given are the sequences, we are going to determine whether the given sequence is an arithmetic or not. If it is arithmetic, we will find the common difference. Okay, so like what I have said, for us to be able to identify whether a given sequence describes an arithmetic or not, okay, we will just find the common difference. Okay, so we will be subtracting two consecutive terms, and when we do subtraction, we start from the number. Okay, for two consecutive numbers, you start from the number on the right and then subtracting the number in the left. So for example number 1, 3, 6, 9, 12. So we will subtract 6 minus 3. So 6 minus 3, we have 3. And then 9 minus 6, we also have 3. And then 12 minus 9, we also have 3. Okay, so as you can see, since the differences, okay, are the same or common, then we can now say that this sequence describes an arithmetic sequence. And then, of course, the common difference is 3. Let's have the next example. So negative 16 minus negative 12. Okay, so we have negative 4. Negative 20 minus negative 16, we also have negative 4. And then negative 24 minus negative 20, we have negative 4. Okay, so when you look at the differences, they're all the same, they're all common. And so therefore, we can also say that negative 12, negative 16, negative 20, and negative 24 is an arithmetic sequence. And as for the common difference, we have negative 4. And then finally, the last example, okay? So when we subtract 5 over 8, okay, minus 3/4, we have negative 1/8. All right, and then 1/2 minus 5/8 is also negative 1/8. And then 3 over 8 minus 1/2 is also negative 1/8. So if you look at the differences, they're all the same. So therefore, example number 3 also describes an arithmetic sequence, and the common difference is negative 1/8. All right. Again, for us to be able to identify whether the given sequence is an arithmetic or not, we just have to subtract two consecutive numbers. And if we found out that the sequence has common difference, then we can say that the sequence is an arithmetic. Okay. Arithmetic sequence can also be represented by formulas. We have two formulas for arithmetic sequence. We have explicit or recursive. We will start first with the recursive formula. So a recursive formula is a formula used to find the next term of a sequence when the previous term is known. And then an explicit formula, this formula is used to find the nth term of a sequence. So whatever term you would like to identify, the explicit formula can be used. So let's start with using the recursive formula. So first example here, create the recursive formula that defines the sequence. An arithmetic sequence is defined by 8, 1, negative 6, negative 13. So since the example given is already mentioned that it is an arithmetic sequence, therefore, there is a common difference here. So the first thing that you will be looking for is the common difference. How do we get the common difference? We will just subtract two consecutive numbers or terms. So 1 minus 8 will give us negative 7. All right? And so therefore, another thing that you can consider is when the sequence is decreasing, the common difference will be negative. And so therefore, we have found out that d is equal to negative 7. After that, we will use the recursive formula. The recursive formula is defined by an, or a sub n is equal to a sub n minus 1 plus or minus d. So in order for you to write the recursive formula of the given sequence, okay, you just have to plug in the value of the common difference to the d in the formula. And so therefore, if we will write our recursive formula for the given sequence, we have an is equal to a sub n minus 1 plus or minus d. Now, since d is negative, we will just be using the minus symbol. And so d is equal to negative 7, so minus 7. So this is now the recursive formula that defines the given arithmetic sequence 8, 1, negative 6, and negative 13. Example number 2. An arithmetic sequence is defined by 10, 6, 2, and negative 2. We will create the recursive formula for the given sequence. First, we will look for the common difference. So for the common difference, again, it is already mentioned here that the given sequence is an arithmetic. So we'll just be subtracting two consecutive terms in the sequence. So 6 minus 10, we have negative 4. And so therefore, the common difference, we have negative 4. All right? And so therefore, using the recursive formula, which is defined by a sub n is equal to a sub n minus 1 plus or minus d, we will again just be plugging in the obtained value of the common difference d to the d in the formula. So you have an is equal to an minus 1. And since d is negative, we will write minus 4. So this is the recursive formula that you can use to find for the next term, okay, given the previous term. Okay, for example, number 3, use the following sequence to create a recursive formula, and then we will use the recursive formula of this sequence to find for the 5th term of the sequence. Okay, so we will look first for our common difference. So for the common difference, we will just subtract two consecutive numbers. 10 minus 18, this gives us negative 8. So therefore, d is negative 8. All right, and then we plug in the value of d obtained in our formula. An is equal to an minus 1. Since again d is negative, so we will write negative 8 or minus 8. Okay, and then after that, we will look for the 5th term. Remember, if you're looking for the nth term, okay, so whatever be the value of the position of the term, that will be the value of your n. So here, n is equal to 5. And we are looking for a of 5 or a sub 5. Right? So using our formula, an is equal to a sub n minus 1 minus 8. We have an is equal to a sub n minus 1 minus 8. We substitute the values for n. So a of 5 is equal to a of 5 minus 1 minus 8. Okay, let's continue here. A sub 5 is equal to a sub 4 minus 8. Okay, and then we'll just identify what is a sub 4. Again, this is your first term, a sub 1, the second term, a sub 2, the third term, a sub 3, and then the fourth term, a sub 4. So we will be needing a sub 4. And so finally, for our a sub 5 now is equal to the value of a sub 4, the fourth term is negative 6 minus 8. And so the fifth term, or a sub 5, we have negative 14. Okay, so that is for the fifth term. Let's have, for example, use the following sequence to create a recursive formula. And then after that, we will also be looking for the fifth term of the sequence. All right? So, first, we will identify the common difference. So, when we subtract 5 over 6 minus 1 half, okay? So, 5 over 6 minus 1 half. So 1 half and 5 over 6. Okay, you can rename this with a denominator of 6. So you can just multiply 3 over 3 because 3 over 3 is just the same as 1. So when you multiply 1 to a number, it is equal to the number itself. So this becomes now 3 over 6 and then 5 over 6. So when we subtract, okay, 5 over 6 minus 3 over 6, this gives us, so 5 minus 3 is 2. And then copy the denominator, that's 2 over 6. Or simply, this is equal to 1/3. Okay. You can also subtract the two middle terms since they have the same denominator. So 7 minus 5 is also 2. And then copy the denominator. Then you reduce it to lowest term. 2 over 6 is just the same as 1/3. And so therefore, the common difference here is 1/3. Okay, so we'll just plug in that 1/3 to the formula in the recursive formula. So you have an or a sub n is equal to a sub n minus 1. Since this is positive, so we have plus 1/3. So this is now our formula. All right, so this time we will look for the fifth term of the given sequence. Okay, so again, we're looking for the fifth term. Don't forget the nth term. N is the position of the term. So when we are looking for the fifth term, therefore n is equal to 5. And so we're looking for a sub 5. Okay, then using the formula that we have obtained, a sub n is equal to a sub n minus 1 plus 1/3. And then since n is equal to 5, so you can just plug in that 5 to your n is equal to a sub 5 minus 1 plus 1/3. Okay, and so we have a5 or a sub 5 is equal to a sub 4 plus 1/3. And what is your a sub 4? What is our a sub 4? This is our a sub 1, the first term, a sub 2, the second term, a sub 3, the third term, and then a sub 4, the fourth term. So we have a sub 4 is 3 over 2 plus 1/3. And when you add the two fractions, 3 over 2, okay, plus 1/3, we have our a sub 5 is, we have 11 over 6. So therefore, the fifth term is 11 over 6. This time, we'll move on to the next formula for arithmetic sequence, which is the explicit formula. So the explicit formula is defined by this formula. A sub n is equal to t times the parentheses n minus 1 plus a sub 1. And for us to define those terms in the given formula, still our a sub n is the current term, the term that we will be looking for. D is still the common difference, and we have an additional term this time. We have a sub 1 or the first term. Okay, in the recursive formula, we need the previous term. This time, we will be needing the first term of the sequence to find for the nth term of an arithmetic sequence. So let's have the first example. Use the following sequence to create an explicit formula. So first, of course, we need to find the common difference. So looking for the common difference here, when we subtract two consecutive numbers, so 6 minus 3 is 3, 9 minus 6 is 3, 12 minus 9 is also 3. And so therefore, the common difference is 3. Okay? So we will plug in this d, which is equal to 3, to your variable d, or the letter d, which is the common difference in the explicit formula. How about this a sub 1? Remember, the first term is a sub 1, the second term is the a sub 2, the third term is a sub 3, and then the fourth term is a sub 4. So a sub 1 is the first term, which is 3. So we'll just plug in those values to the formula so that we will have the explicit formula now. So a sub n is equal to, our d is 3 times the parenthesis n minus 1 plus our a sub 1, or the first term, is 3. Okay, so we will be using this formula so that we would be able to find the nth term of a given sequence, which is the next question. Find the 8th term of the sequence. So we're looking for the 8th term. Again, don't forget, when we are looking for the nth term of a sequence, whatever be the position of the term, that will be the value of your n. So n here is equal to 8, and we are looking for the 8th term, which is a sub 8. Okay? And we will use the formula that we have obtained from the given sequence described. So you have a sub n is equal to 3 times our n is 8 minus 1 plus our a sub 1 is 3. And then we'll just simplify. So a sub n, so a sub 8 now is equal to 3, and then 8 minus 1 is 7 plus 3. Okay? And so a sub 8 is equal to 3 times 7. Yeah, 3 times 7 is 21 plus 3. And so finally, for a sub 8, that is equal to 24. Meaning to say, if you will get the 8th term, okay, we will get 24. So by adding 3 each time to get the next term, so 12 plus 3, that's 15, plus 3, that's 18, plus 3, that's 21, plus 3, that's 24, which is the 8th term. All right? So for the explicit formula, you just have to substitute to the formula or plug into the formula the common difference and the first term. Okay, let's have another example. Use the following sequence to create an explicit formula. The sequence given is negative 12, negative 16, negative 20, and negative 24. And if we will be looking for the common difference, negative 16 minus negative 12 will have negative 4, negative 20 minus negative 16, we also have negative 4, and the negative 24 minus negative 20 is also negative 4. And so the common difference is negative 4. All right? Okay, so again, the common difference is negative 4. So we can now create or write our explicit formula for this sequence. So we have a sub n is equal to, the common difference is negative 4, and then n minus 1 plus, okay, since our first term is negative, so instead of writing plus, we will write minus 12. So this is your A1, this is your A2, this is your A3, this is your A4, and we will be needing a sub 1. Now, we are looking for the 18th term, all right? Again, if you are looking for the nth term, okay, 18, that's the position of the term. So therefore, n is equal to 18. And we are looking for a sub 18. Okay? Let's use the formula. A sub n is equal to negative 4 n minus 1 minus 12. And let's plug in the value of n. You have a sub 18 is equal to negative 4, right? 18 minus 1 minus 12. Let us continue. So we have a sub 18 is equal to negative 4 times 18 minus 1 is 17 minus 12, right? And then let's simplify. We have a sub 18 is equal to, now negative 4 times 17 will give us negative 68 minus 12. And what is negative 68 minus 12? So we have a sub 18 is equal to 80, negative 80. All right, since they're both negative, 68 plus 12 is 80. They're both negative, so we will copy the sign common to them, which is negative. All right, so that is how to use the explicit formula.